Hello, if you are not in class, we are starting in Chapter 6. We're going to do some review work there. So whatever people or whatever questions are, and we're going to try to cover 6 and 7 today, is that it gets us through the first half of our material. So if we treat this just like we did last week, let's go 6-1 and take any questions there. Any questions from 6-1 dealing with frequency and histograms? What makes a histogram a histogram? Why is it called a histogram and not just a bar graph? So if I look at the picture of a histogram, what do you notice? The bars what? The bars are connected. They're always going to be touching. And each bar, does that represent a single value? Like this bar right here, what's it representing? Yeah, it's a range. So histograms are used to graph frequency within ranges. So your bars always have to be touching, and you either can write the range below it as like this is the range that I'm talking about, or you can write the range as in here's my start, here's my end, then my start, my end, then my start, my end. So either way, these are the two different ways that we make histograms. Frequency is always going to be your y-axis. Any questions from that homework or that lesson? I kind of guessed as much. So 6, yeah.
I was gonna say like how do you actually know what to do for how do you make a frequency table? Like how do you know what to do with it?
What do you mean? Do you have a question from the lesson or the homework? Something specific?
Just from the notes. For example, problem number 1.
So did you watch through the video?
Yeah, but that really didn't I didn't fully understand the.
So like this one, the marathon times?
Yeah.
So, hold on, let me pull up a better version of this. Where's my other Math 1 folder? So it tells me in exercise 1 and 2 use the data to make a frequency table, but it doesn't tell me anything about the specific ranges. So when I look here at my values, I've got a lowest value, of 135, and a high value of 246. Right, so I'm going to have to graph these frequencies, but I need to choose some ranges. So how big do we want our ranges to be? We could do like 5 or 10 or 20 or... The bigger the range you get, the more people that are going to be lumped into that range. So I might choose, let's make my range 15 or something like that. So if I then make a frequency table, I'm just making a table representing how many people had what happen. So I here might put, times. And I'd start with, maybe I start at 130 just to make my life easy and go to 145. And then I go from 146 to 160, and then 161 to 175, and then 176 to 190, and then I would keep going like that, but I just set up what are my ranges of times. Then my next column would be like frequency or how many people had that time. So in the 130 to 145, I look at, well, I've got 135 in that range, and that's it. So I've got 1 for my frequency there. Then 146 to 160. No. So we've got 0. Then my 161 to 175. I look for how many are in that range. Here's 1. Here's 1. Here's 1. So now I'm starting to get more closer together. So that maybe means this person finished with a low time. They were probably the winner. This might just be a sample of the data, or it might be everybody. And if they were obviously the winner, but maybe their time was dramatically faster than everybody else's. So then most of our people are going to have slower times. So I've got 3 in my next range, 176 to 190. I just keep doing the same thing, figure out how many are there. Now, when we talk about a cumulative frequency table, this is where a lot of people started to have questions with a cumulative frequency table. Over here, you would have a total column, for cumulative frequency, and I would say, well, the total that I've had up to this point is 1. The total that I've had up to this point is still 1 because I did not add any more. But now the total of everybody under 175, now that total is 4 because I sum everything in that column to get to my total column. So if I look at 176 to 190, I've got one more there, and that's it. So then my total over here would become 5 because it's like how many total people have I seen in this column. So that's a cumulative frequency table, though. Does that help?
Yeah.
Okay. Other questions, 6.1. So this did not ask you for a cumulative. I just wanted to talk about it since we were discussing it. This just asked for a frequency table. Nothing else from 6.1. Going once. Going twice. 6.2, talking about measures of central tendency. So that was our mean, median, mode, range, some deviation stuff gets covered there. As we get into dispersion, your quartiles. Sometimes people have issues determining their quartiles. What does the root word quart, Q-U-A-R-T, mean? 4, yeah. So we break it up into 4 sections. You find your median, that breaks my data into 2 pieces. And then each of those chunks, my low chunk, my high chunk, we find the medians again, and those break it up. The hard part is when your median is 2 values at the same time, then we average it and we kind of make up a new value that shows our break, but we don't use either of those numbers. So be careful with that. If you have an even data set, it gets a little tricky. Questions on 6.2? 6.3, box and whisker plots. This used those quartile breakups. You'll have your first 25% of your data out here, your next 25% inside the box to the left, your next 25% in the box to the right, and your final 25% out here. If the whisker does not actually connect, that means it's an outlier and it's far away from everything else. But most of the data that we use should have whiskers connecting all the way out. Even if it's kind of far out for the data, it should still get connected. Questions? Making box and whiskers. Scatter plots and trend lines. How do we create a trend line off a scatter plot? Yeah?
Okay, so I have a question in like the homework is question 3 and 9. It's like use a table and a graphing calculator.
This is 6.3, right?
6.4.
6.4. Mm-hmm. I like which one?
3.
So to make a scatter plot of your data, you want to go. Give me a minute, just so you can see. Ooh, actually, do I still have my emulator? If I have my emulator, I don't need to use that little camera. Yay! You can't find this anymore. You used to be able to find a TI emulator to download, and they kind of tighten things up. So if I have my graphing calculator here, I don't think I can make this. Cannot make this any bigger. Can you see that, JD? So what you want to do is go to. So you're going to try to make a table, right? But you don't want a table that they already have set up because this table is dealing with your y equals, right? So all of this relates back to my graph. So what I actually want to do is make a list of values. So I'm going to go, when I'm on the emulator, I always have a hard time. Give me a second. I need to get out my actual calculator. I can't see that thing. It's kind of blurry. So stat. Right here, your stat button. See that above it? It says, well, you can't see it here. But if you have a calculator, you see right above stat, it says list in blue. So I'm going to hit second and go to stat, except I'm actually going to list. I'm going to go to list 1. I'm going to input these values, but I need to edit that list. So notice that when I clicked on list 1, it just dropped L1 there. That's not what I wanted to happen. I want to edit my list. Let me play with this for a second. List. Ah, all right. So it's this weird, tricky thing that you got to remember. So even though I need to hit second list to get to the lists, if I don't hit second, that's how I get into the edit menu. So I always forget about that little, like, when you have done it before, it starts to, like, you just kind of hit a couple buttons, then you remember how you did it. So it's all about practices, so you're familiar with it. So when I just hit stat, it's the same list button, but it's just a different menu. I'm going to go to edit, and then it shows me my lists that I can change what's in my lists. If you've never used a list before, it's going to be blank. If you've used a list before, it's going to have some values. So I can make my L1 list my years, and then I can make my L2 list my populations. So I could make this 1960, then 1970, 1980. I'm not going to do the whole thing. So that's how we edit list 1. Then I bump over and I can edit list 2 and match up with the population values. So 9706, 10652, 10798, and 10847. So then I can go back to my graph menu, and actually what we want to do is second y equals, because that's going to take you to your plots menu. I'm going to turn on plotting, so I go to plot 1 and I say I want it to be list 1 and list 2 plotting on the x-axis and the y-axis, or I could flip those if I wanted the other way around, but you just make your lists x, y, and make it nice. I can either make my plot boxes, crosshairs, or dots. Dots are kind of hard. So notice it's blinking up here incessantly because it wants you to turn it on. In the plot menu, won't do anything if I don't turn it on. And then I can choose whether it's going to show me like a frequency histogram, a connected dot plot, a disconnected dot plot, a box and whisker plot that might disconnect if it has an outlier, a box and whisker plot that will stay connected. So I've got all these options. I'm just going to leave it as a dot plot. So then I go into my graph. And what's the problem right now? Yeah, my window's way off. So sometimes I can go to zoom and do zoom fit, but a lot of times this is not going to work very well because zoom fit just kind of like does everything for you. And sometimes it can't even figure out what it needs to do. So look at your values. If my years were my x values, let's just go into my window and make my x values start at 1960. And even though I didn't graph it all the way, I'll make them end. Let's go a little bit further. Actually, I'm going to go back up here and do 1950 so I can see my 1960 point really easy. And I'm going to do 2020 for my max. And then I'm going to move my x scales by tens. So every time I have a new x mark, that's 10 years, and it's going to match up with the table that I have. I then go to my Y menu, or my Y minimum, and I see, well, that's my population. It starts at 9,700. Let's just do 9,500. A little lower than that, nice even number. Goes to 11,500. Let's just do 12,000. And then since I have a bigger gap there, I'd probably want to at least go by 50s, maybe even 100. But let's just try 50s and see if that works. Actually, 50s is going to be I'm going to do 500 actually. Yeah, just so I don't have a lot of tick marks. And then I graph, and there's my plots. So then I can there's functions in here to model the best line of fit, and there's other videos to go through that and stuff, but that's the easiest way to get points plotted on your graph. Does that make sense, or you want to see it again?
Yeah, it makes sense, but like, how do you find the
so it's the stat button is your best friend. You go to stat, edit, change your lists, then go to your second stat plot up here, turn it on, tell it what lists you want, L1, L2, and what kind of plotting you want it to do.
How do you make the equation out of the graph?
What do you mean make the equation?
It says write an equation for the line of best fit.
So I think did I not have a little tutorial thing about that? You watched the video and it didn't help. Let me see if I can find a really easy tutorial. Finding Dory. Finding the equation. Who is this?
In this video, you'll learn how to determine the equation for a line of best fit. In an example in front of you,
It's not wonderful. All right, well, so there's a really, really basic way that involves like just actually graphing it and drawing it. So one thing that I could do, and I'll see what Khan has to help, but one thing that I'm able to do is take, where's my emulator? I can take these points, and if I put more points on there, and I could draw a line through it to say, okay, this is probably about the best line. I'm talking like me physically drawing, not like typing it into graphing. And then I could figure out, well, what points does it cross through? Because it should cross through at least 2 points, and you want to try to cross through as many points as possible. Have as many above the line as you have below the line. You're trying to equalize that out. And then I could actually just look at the line and say, well, where does it hit the y-axis? The 2 points that I cross through, what's the change in y and the change in x to find that slope? And then I can make my equation based off of that. Let me see what Khan has, because I think he has a good one. This is a really interesting video.
The graph below shows the percentage of American adults who smoke over time. Assuming the trend shown in the data has been consistent since 1945, use the graph to estimate the percentage of American adults who smoked in 1945. So let's see what's going on here. The horizontal axis here, they say years since 1965. So this point right over here, this is 0 years since 1965, so this really represents 1965, roughly 55, and they don't
You can always come back in here.
So there are adults who smoked in 1945.
So this is kind of what I'm talking about. When we sketch the line through, we're trying to go through as many points as possible. And for every point that falls below the line, we'd like there to be another point above the line, but sometimes that doesn't work out perfectly. So sometimes there will be more below. And if we go through a lot of the points, and that's still good. Like if we don't have the even above and below, that's okay if we're going through a lot of the points.
You could view as 20 years before 19.
So, like, I don't even need to let his explanation play. You can always look up Khan. His videos are great. But I can look at the y-intercept here and find out that's about 40, 41, 42, somewhere close to that. I could grab this point, because my line goes through that point really well, and probably this point, you want something far away from it. Figure out your slope based off that delta y and that delta x, because we're just estimating the equation. There's not like a perfect, this equation is it. There's a lot that are very close. That's why we're saying we're estimating. But that's the easiest way to do it when you can actually draw it. I forget if there's... This is the way to cheat. When I say cheat, it's not really cheating, but
Hey guys,
it's not really
today
using
I
your
want to show
brain.
you how to make a scatter plot on your graphing calculator.
So we know how to make a
Find the
scatter
equation
plot.
of its... After you're finished entering the data, go to second, y equals. We want to make sure that stat plot 1. Press enter.
I like
And
this.
now
I need
it's
to get whatever
highlighted.
software he has.
Now we want to hit graph.
Okay, so we've got our
Notice
points.
how not all of the dots appear on the graph.
All right, fix your
In
window.
order to see the entire, then scroll
Yeah.
toward
Fix your window.
the
Fix your
best
window.
view of our scatter plot.
I just forget
Now that
where
we
it
can
is
see
in
our
our
entire
menu.
scatter plot, it's time to calculate the line of best fit. Hit the Stat button again, and this time, press the right arrow and move the cursor over to where it says Calc. In the Calc menu, scroll down
Ah!
to option 4, LinReg, which is short for linear regression. You could also just press 4.
Forgot about
Then
this.
press enter. Then press enter again. A is the slope of the line of best fit.
So, I just forgot how to get to it in the menus. Like, you're growing up in this kind of tricky era to negotiate because the internet is so important and stuff, but it's really powerful for being able to quickly get the answers to your questions. And I know that this guy is pretty decent because, first off, his name is not like Joe Schmo. It's Graphing Calculator Review. He must care about like instructing things with a graphing calculator. And this video has 100,000 views. I can probably trust this video. So let's go try that. I know I did not have all of the points in here, but so like he said, we go to Stat, go over to Calculate, and we can go to Linear Regression, hit it, hit Enter again. There's my approximate values. Because with what I was graphing, the y-intercept here would actually be the population at year 0. So it doesn't make much sense, but that's what it was. So our equation would be y equals approximately 35.5x plus negative almost 60,000.
Okay, because I did that. That was up on YouTube too.
Okay.
I got like completely like the answer key. And
Well, but I only put in 4 points. So if I want that to be more accurate, I have to come back here and edit my list to put in the rest of the points that I didn't have.
okay.
So where did that go? What are we on? Homework?
Yeah, I get what you're saying.
Yeah. So if I add in the other points, then it would get a lot more accurate. What's up?
Oh, I just have.
I'm here, so I
Sweet.
might be checking
Well, we're going over chapter 6. So do you think you need to go over chapter 6? Okay. So there you go. Thanks, bud. I'm going to take attendance here in like a little while because I know people are trailing in. What do you need, dear?
I have questions on this
Okay, can you hang on to them until we get done with whole group? Just skip it for now. Yeah. Other questions from 6-4. If you do not have a graphing calculator at home, I have them here. First thing I like to give you is this because it's fun and it's new and it's fancy, but I've got other ones as well. So I've always got, if you want to come in and work to do that stuff, I've got the calculators here. 6-5. By the way, if you want more practice with this, what I really like about Khan is then everything with a star is practice exercises. Everything with a play button is a video. So I can watch the video and then I can go and practice it. So yeah, I like his site a lot. Anything else? 6-4. Trend lines. Two-way frequency tables. You're going to have two column or a column of totals and a row of totals. So you really have like a little frequency table, and then you have your total columns on the outsides. Any questions? Two-way frequency tables. Anything else from chapter 5 at all? Or 6? Good catch. I saw you're like, what? All right, chapter 7. I'm going to go notify everybody that we're going to work on chapter 7. By the way, if you guys haven't noticed, when I go over here to my materials, if you see the drop down, it's because there's so much in my materials page, it wants to help you more quickly get where you're trying to go. So you can save some time by using that little drop down arrow. I'm going to stop this and go tell everyone.